everyone. Today I'm going to read about water supply engineering, and in water supply engineering I'm going to talk about treatment of water. As I've last time, I'm going to just do a quick revision of the treatment of water. Water contains impurities which are suspended and dissolved, and out of those suspended and dissolved, both are divided into organic and inorganic. And inorganics are those which are non-biodecomposable, while organic impurities are those which are biodecomposable. Or we can say that organic impurities are those which can be acted by the microorganisms, and they seek energy from them as a food. So after this, we will talk about the whole process of treatment of water. The process of treatment of water consists of screening. After that, it is aeration, then sedimentation, then coagulation and flocculation, then filtration, and then disinfection, which is the last treatment of water. This should be remembered, that this disinfection should be the last treatment given to the water. The sludge that has been accumulated during the treatment is went to the sewage treatment plant, which we will discuss in wastewater engineering. So first we will discuss about screening. Screening consists of coarse screening and fine screening. Coarse screening are rods which are 25 mm in dia and 75 to 100 mm spacing between them, and they are placed at a vertical at an inclined height of 3 to 6 vertical is to 1 horizontal, or at an angle of 45 to 60 degrees in order to facilitate raking. Coarse screens are used to remove the heavy suspended impurities, which are like branches of trees, twigs, leaves, and animal bodies, and all those big suspended impurities are removed by the coarse screens. And fine screens are used after coarse screens in order to remove the fine suspended impurities, which are generally avoided due to the high head loss which has been produced. Just because high head loss is produced because they used to get clogged. So after fine screens are just a wire type mesh in a circular form, and after fine screen, what we are going to do is we are going to do the aeration process. The aeration is done. Pre-chlorination is also done. Pre-chlorination is a thing which is done in order to satisfy the chlorine demand before the treatment of water, and also it precipitates the iron and manganese into the water, so that later on they do not do trouble to the water. So aeration is a process in which the air is induced inside the water in order to remove the taste and odor. It also removes carbon dioxide, which provides corrosive property to the water. It removes H2S, which removes taste and odor. It chemically reacts with the organic matter in order to remove it and precipitate it. It precipitates iron and manganese ions as well. So this is all about aeration. After aeration, aeration are four types. We're not going to discuss about those types, but we're going to discuss what are those types. First type of aeration is gravity tower. Gravity tower is aeration in which is done with the help of gravitational force. After that, it is spray tower, then diffused air type of aeration, and then cascade air tower, in which steps are provided in order to provide the turbulence into the air. After that aeration, we do sedimentation. Sedimentation is a process in which the whole water body is made still in order to settle down the impurities, fine suspended impurities. So the detention period, what is the detention period? Detention period is a time up to which the whole water body is settled. That is also known as the sedimentation time. But there should be some settling velocity of the particles, and the concerned particle. Well, the concerned particle is a particle which can be settled in the sedimentation tank or the settling tank. Now we will talk about the settling velocity equations. There are three equations of settling velocities. One is this: Vs is equal to G into G minus 1 d square upon 18 nu. Nu is kinematic viscosity, where d is less than 0.1. Or we can write 418 G minus 1 d squared 3t plus 70 upon 100. But when d is greater than 0.1 and less than 1, we use this equation, which is 418d G minus 1 3t plus 70 upon 100. When d is greater than 1 mm, sorry, this is not 0.1, it's 1 mm, we use 18 root gd into g minus 1. So this is the equation of settling velocity. Now there are two types of sedimentation. One is plain sedimentation and other is sedimentation with coagulation. So what is coagulation, what is percolation, we're going to discuss in the next lecture. Up till then, it's a very goodbye from me. Thank you. Vande Mataram. Jai Hind.